Welcome back to lesson 8.9, notes 4. Well, today we're still working with the quadratic formula, which of course by now you have memorized. And so you know what, why don't you take a moment and would you open the white space up here, would you, from memory, write down the quadratic formula. No cheating and watching the magic strokes on the smartboard. Do it yourself. I think someday they should probably just put that on my tombstone because, you know, it'll never leave me. Okay, so here's what we're going to do today. We're going to use the discriminant, first of all. We're going to find the discriminant first. We're going to kind of do this out of order from what we've been doing. We're going to use the discriminant to determine the number of real solutions, and then we're going to find them. Now, trust me, I'm not creating more work for you. Just bear with me. Okay, so in number 1, is it ready to identify A, B, and C? That's right, it is. So A equals 9, B equals 6, C equals 1. Stop, because here's where things are going to change up a little bit. I want us to just find right now, because we're going to use the discriminant to find out how many solutions there will be. So, but of course remember, the majority of us, if not maybe all of us, are using that as a plus, a negative for AC. So now we're going to substitute our B value in. And we just stay in the habit of substituting, going in parentheses, then we don't get ourselves in any trouble with Legrand when she says that has to be in parentheses. Sometimes it doesn't, other times it does. So just do it all the time. You don't have to worry. 9 squared, 81. A negative 4 times a positive 9 times a positive 1, you got it, negative 36. Well, did anybody catch that I did something wrong here? You are so good. And I hope you weren't just like, doing what I was doing, because you know what? Seriously, the B value is not 9. The B value is 6. It's the A value that's 9. So we're going to go back and make 6's in place of our B's. Let's try this again. 6 squared, right, 36. Negative 4 times 6 times 1. Negative 36. Done messing with you. This is, our discriminant is 0, isn't it? So that tells us right there that we have how many real solutions? Well, there's only one square root of 0 and that's 0 itself, so there's only one real solution. So we expect that when we are done using the quadratic formula, we have one solution. And we expect that the discriminant is 0. So, are you kidding me? Do you think we're gonna find it again? No. We're gonna now substitute into our quadratic formula. We're gonna have the opposite of our B value, which happens to be 6, not 9, plus or minus the square root of, we already know what our discriminant is. It's 0. All over 2 times that, 9. Okay, so we have here x equals negative 6, well, what's the square root of 0? 0. And when you add 0 to negative 6, you're still going to have negative 6, right? If you subtract 0 from negative 6, still going to have negative 6 upstairs. So then we're just going to have negative 6. And we have 18 downstairs. And how many, 18s can you take out of 6? I don't even care about the negative sign right now. How many 18s can you take out of 6? Well, not very much. Not 3. So we are going to leave this as a simplified fraction. A negative divided by a positive is a negative, and 6/18 is 1/3. I can almost hear you, even though I'm in the classroom all by myself. So our one real solution is x equals negative 1/3. And hopefully you remember that that means if there's only one real solution, there's only one zero. If there's only one zero, that means the vertex is sitting on the x-axis. You got it. Okay, let's go try the next one, number 2. Okay, I know that there's several of you that you're going to be like, I only want to make one move, so you're going to move the 3x squared over to the other side. And so I'm going to guess that maybe I could just go along with you. Just kind of reading your minds right now, I just think that's what you might want to do. So let's get it in standard form right away, so that our next move can be to identify A, B, and C. Reminder, we're using the discriminant first to help us decide how many real solutions this should have. So b squared plus a negative 4ac. Let's see if I can do it right this time. 5 is our b value. I was so worried about the parentheses last time I couldn't concentrate on the correct b value. Plus negative 4 times our a value of negative 3 times our c value of positive 10. Okay. So I have 5 squared, 25. And negative 4 times negative 3, positive 12. 12 times 10, 120. Our discriminant is 145. So we have a positive discriminant. Every positive number has 2 square roots. So we end up with, this one better end up with 2 real solutions. And hopefully, right now, something went off in your brain, some alarm went off in your brain that said, 145 is not a perfect square. When the discriminant's not a perfect square, we're going to have to do what we did yesterday, which is approximate. So let's go put it into our quadratic formula. X equals the opposite of our b value plus or minus the square root of 145. We already know it, don't do it again. All over, nice long fraction bar, 2 times our a value of negative 3. Okay, we are going to have here x is equal to, we haven't done any, we are going to be approximating in this step, aren't we? So you know what? Now we need our approximately equal to sign because we are going to get rid of the radical. So x is approximately equal to negative 5. Opposite of 5 is negative 5. Plus or minus. Now is when we're going to use our awesome rounding skills. We're going to take the square root of 145 and round to the nearest hundredth. Well, on my calculator, it's 400ths with a 1 behind it in the thousandths place. So that tells me that 400ths is going to stay 400ths, not jump up to 500ths. So I'm going to have 12.05 and downstairs a negative 6. So here we are at the point where we have to break it into two problems. X is approximately equal to negative 5 plus that 12.05 all over negative 6, and X is approximately equal to our negative 5 minus 12.05 all over negative 6. So of course, remember we had this discussion yesterday. We want to make sure that we, you know what, why did I say that we weren't going to round it and then I did? Okay, I want you all to know that I'm doing this at a point when it's probably time for me to have supper. So would you go on a race if you were, thinking that I knew what I was doing? And make those 12.04s, not 12.05s. Sorry about that. I'm full of all kinds of mistakes today. Now, again, back to the story of if you're going to use your calculator to do it all in one fell swoop. Reminder, when we put it into our calculator, the numerator must go in parentheses before we do our divided by negative 6. So X is approximately equal to, our first one should come out to a negative 1 point. Second, I want to make sure I don't make a mistake again. I'm going to try and do this right this time. So negative 5 plus 12.04 divided by negative 6. Rounded to the nearest hundredth, it looks like it should be negative 1.17, because there was a 3 in the thousandths place, so those 1700ths stay 1700ths. And my other one should come out to looks like I don't have to do any rounding this time, but it still is approximately equal to because we rounded earlier in the problem. And the other approximate solution should be 2 8400ths. Okay, so we had a 1 real solution one, a 2 real solution. Something tells me that maybe we'll get a no real solution one. So reminder though, when we have 2 real solutions, that means there are 2 zeros. 2 zeros means this parabola crosses the x-axis in 2 locations. Okay, so let's go on to our number 3 here. In standard form already? Cool. ABC. Use the discriminant to decide how many solutions. After substituting into our discriminant part of the formula, we should have 3 squared is 9. Negative 4 times 1 times 7 is negative 28. 9 plus negative 28. In my world, and of course my world tonight is a little bit fuzzy. In my world, that's negative 19. See if you agree with me. If the discriminant is negative, that would mean we're trying to take the square root of a negative number, which is not possible. So we know there are no real solutions. There are no real solutions, that means there are no zeros. If there are no zeros, that means this parabola will not cross the x-axis. And since it has a positive a value, I'm thinking it's opening up. If it's never going to cross the x-axis and it's opening up, that means it has a vertex somewhere above the x-axis. And so the nice thing about if we do this discriminant part first, when we find out that we have a negative discriminant, we can just stop and not even finish the rest of the quadratic formula now, because there's no sense in doing it, because it would break down anyway at the point where we would substitute this under the radical sign, and we would not be able to continue on. We would not be able to take the square root of it. So we're going to just stop and say there are no real solutions to this problem. No zeros. No places it'll cross the x-axis. Okay, this is what you add on. You've got 4 sets of notes now so far in 8.9. Anything can happen in your homework now that you will be doing for tomorrow. So let's use this method though. Let's practice this finding the discriminant first, then being able to just, plop it in. After we found it, then we can do this and save that substitution step there. Okay, good luck. See you all tomorrow.